So, hello, very good evening to all. I hope my voice is audible to all of you, right? So, if face any problem related to my screen visibility or my voice, you can just text me, right? So that we start our today's session, right? So, in the last class, we already discussed about the surface chemistry, important thing, various type of absorption and terms, and how will you distinguish colloids? How will you classification of colloids as well, right? So in today and tomorrow classes, basically in today class, we are going to solve numeric questions related to surface chemistry, previous year question of NEET, JEE, and advanced questions related to surface chemistry, right? So this is what we are going to do in the today class, right? Clear है सबको? चलो. So this is the surface chemistry class 12, second part. Preparation of colloids, right? तो जल्दी से फटाफट इसको समराइज कर लेते हैं. Let's quickly summarize this and after 5 to 10 minutes, after just revising the main concept, we are going to solve questions, right? So how colloid will form, right? Good evening, sir. JNB Visakhapatnam. Okay, beta. Very good evening. So preparation of colloid, right? So how lyophilic and lyophobic colloids will formed and what are the method for their preparation? ठीक है, बड़ा important topic है. So lyophilic colloids may be prepared by simply dissolving of warming the solid with the liquid dispersion medium. It means this type of colloid may be prepared by simply just dissolving of warming, right? Just dissolve karo or heat karo with solid with the liquid dispersion medium. On the other hand, lyophobic colloid have to be prepared by the special method, right? Because lyophobic colloid is very difficult to prepare, right? On the other side, lyophilics are very simple to prepare. They are the water-loving species, where the lyophobic are the water-hating species, right? So there are the two methods for the preparation of a lyophobic colloid that we are going to discuss, right? That are what are the two methods for the preparation of the lyophobic colloid. So the first method for the preparation of lyophobic colloid is breeding arc method, also known as electrodispersal. So always remember what do you mean by this term, breeding arc method, or we say electrodispersion method. Okay. Now, it is used to prepare hydrosol of the metal. What do you mean by this term, beta? Hydrosol. Can anyone explain me? What do you mean by the term hydrosol? Right. We already classify the colloid in we see what is hydrosol, what is aerosol, right? So it is used to prepare hydrosols of the metal like silver, gold, platinum. An arc is stuck between the two metal electrodes held close together, right? When deionized water. इसमें क्या करते हैं basically? एन आर की स्टक एक आर को दो मेटल के बीच फंसा देते हैं और फिर उसको तोड़ने का कोशिश करते हैं. ठीक है, आर की स्टक बिटवीन द टू मेटल इलेक्ट्रॉन हेल्ड क्लोज टुगेदर. The intense heat of the spark vaporizes some of the metal and the vapor condenses under the water. So this intense heat of the spark vaporize some of the metal. Metal will get evaporated, and this evaporated metal can be condensed with the help of water. Trace of QOH are added to water as a stabilizing agent, right? So this is the diagram wise breeding arc method. We can observe this. So here we can see that this is two are the metal electrodes. So these two are the metal electrodes. One is here and one is here. So these two are the metal electrodes. And this is deionized water, right? This is a deionized water. And what is this beta? So this is an R, right? This is an R. And this is a cooling material, that is the ice bath, right? So this is the cooling material. So they will produce a very arc will produce a very high heats. Due to this, the metal get evaporated and water, cool water condense this, right? Cool water, this ice bath make this water cool and they condense this, right? So this is the breeding arc method. Clear है सबको यहाँ पे? What is breeding arc method? Lyophobic colloids बनाने के लिए यूज हो रहा है. And it is used to prepare hydrosols of the metal like silver hydrosols, gold, platinum, etc. Okay. Now, what is peptidization? Very important thing. What is peptidization? So in peptidization, some freshly precipitated ionic solid are dispersed into colloidal solution in water by the addition of small quantities of electrolytes, particularly containing a common ion, right? So what is peptidization, beta? In peptidization, some freshly precipitated ionic solid, right? So in peptidization, some freshly precipitated ionic solid are dispersed into colloidal solution. मतलब freshly prepared जो है ionic solids उनको convert करते हैं colloidal solution in water by the addition of small quantities of electrolytes, particularly containing a common ion. ठीक है? Now, the precipitate absorb the common ions and become electrically charged. So जो ये precipitate होते हैं, what they do? They absorb the common ions and become electrically charged. These charged particles then split from the precipitate as a colloidal particle. So this is all about the peptidation. Just reverse of this peptidation is known as coagulation. Always remember the reverse of this peptidation process is known as coagulation. So in peptidation, some freshly precipitated ionic solid are dispersed into colloidal solution. मतलब यहाँ पे हम क्या कर रहे हैं? Precipitate to colloidal solution we are preparing. We are preparing here from precipitate to colloidal solution. ठीक है? Colloidal solution. From precipitate to colloidal solution. This is called peptidation. And now when you prepare colloidal to precipitate, then this is known as coagulation. So these two are the differences, right? By adding some suitable electrolyte. So here we have a fresh precipitate of FeOH3. Now we add FeCl3. Always use such electrolyte in which some common ions are there, right? So this is the fresh precipitate of FeOH3. As we can see that this will be settled down the bottom. It will show that this is a precipitate in nature, right? That is a solid dissolved in liquid, right? Insoluble solid they have, so they behave as a precipitate. So the fresh precipitate of FeOH3, now when they are treated with the FeCl3 electrolyte, they will convert it into a salt, that is a colloidal salt, right? So the dispersal of a precipitated material into colloidal solution by the action of the electrolyte in the solution is termed as peptidation, and the electrolyte is called peptizing agent. So always remember the electrolytes को क्या बोलेंगे? Peptizing agent, and the process is called peptidation. So सबको ध्यान में आ गया what is peptidation? That is the process of converting precipitate into salt. That is precipitate into colloidal salt is known as peptidation by using a suitable electrolyte, which is also known as peptizing agent. Like AgCl can be converted into a salt by adding HCl. FeOH3 yield a solution by adding FeCl3, as we can see that. So this is all about the peptizing agent and peptidation. Now, the second is aggregation or the condensation method. So in this method, colloidal sized particle or molecule are built up by aggregating ions or smaller particles. So some important aggregation method are like double decomposition, right? So the arsenic sulfide salt is prepared by passing a slow stream of hydrogen sulfide gas through a cold solution of arsenious oxide. So this is the method of aggregation or condensation method. Aggregation, as the name suggests, when this molecule colloid sized particle or molecule are built up by aggregating ions of the smaller particles. Okay? Now, purification of colloidal solution. So the colloidal solution obtained by the above mentioned techniques remain associated with some impurities of the electron. So these impurities make the salt unstable. Thus their removal is necessary. So this process is called purification of the colloidal salt. So I hope this is clear. What is the purification of the colloidal salt? That is the colloidal solution obtained by above mentioned technique remain associated with some impurities of electrolyte. These impurities make the salt unstable. Thus their removal is necessary. So this process is called purification of the colloidal salt. Clear? Sure. Now, the first method for the purification of the colloidal salt is called dialysis. So what is this dialysis basically? So the process of removing ions or molecules from a salt by diffusion through a SPM, that is semi-permeable membrane, is called dialysis, right? The process of removing ions or molecules from the salt by diffusion through SPM is known as dialysis. In this process, a sol containing a dissolved ions or molecule is placed in the bag of permeable membrane, either animal bladder, parchment paper, and cell phone film. Dipping in water, the ions diffuse through the membrane. These all animal bladder, permanent paper, and cell phone seeds are the natural occurring semi-permeable membrane, right? So dialysis, this is here we can see this. By using a continuous flow of water, the concentration of electrolyte outside the membrane is made zero. That is a ferric hydroxide salt can be purified by this method. So this is we have a salt in this bag, and this is water, and this is called the bag of permanent paper, or we say SPM, semi-permeable membrane, right? This is the process of dialysis. What is electrodialysis then? If you know the dialysis, what is electrodialysis? These all are the purification method, always remember. So in this process, dialysis is carried under the influence of electric. So अगर dialysis normally करते हैं, they are known as dialysis. अगर उसी dialysis को, if we done this dialysis under the influence of electric field, under the influence of electricity, then this is called electrodialysis, right? Why? Because the potential is applied between the metal screen supporting the membrane. This seeds increase the migration of ion to the opposite electrode. Hence, dialysis is greatly accelerated. Means dialysis is a slow process. But if you compare with the electrodialysis, then electrodialysis, this will be their speed is more as compared to dialysis. Their speed is accelerated. This method is not suitable for the non-electrolyte impurity like urea. So this method is suitable only for the electrolyte impurities, right? Not suitable for the non-electrolyte impurity. Now let's see some optical properties like Tyndall effect. So this is a very common effect of this chapter, circuit chemistry, right? Tyndall effect. So what is this Tyndall effect, right? So when a strong beam of light is passed through a sol or a say colloidal sol and view at a right angle, the path of the light show up as a heavy beam or a cone. This is due to the fact that the sol particle absorb light energy and then emit light in all direction in space. Scattering of light, right? That is the scattering of light is basically known as optical Tyndall effect. This illuminates the path of the beam in the colloidal dispersion. The phenomena of the scattering of light by the particle is called Tyndall effect, right? So this is all about the Tyndall effect. That is what is optical properties. Basically, we can remember Tyndall effect, right? Scattering of light through colloidal particle. So this is known as a Tyndall effect. Now, the illuminated beam or cone formed by the scattering of light by the sol particle is referred as Tyndall beam or Tyndall effect. Now, what is charge on the colloidal particle? So actually in the colloidal solution, the colloidal particle always carry an electric charge which is same in nature. Either it is a positive or negative. Some common solve with the nature of a charge on their particles are given below, like a positive charge solve. So you need to remember, because many times the question is coming from for the coagulation of the positive charge, what do you need? Negative charge. For the coagulation of negative, what you need? Positive. So you must know which one is a positively charged and which one is a negatively charged source. Then only you are able to identify for which which coagulating agent you use. So positives are salt like hemoglobin, that is the blood, basic dye stuff, methylene, blue salt, oxides, hydrated metallic oxide, and Fe2O3.XH2O. These all are the example of the positively charged salt. Similar, what is negatively charged salt? That is the metallic sulfide, AS2S3, Sb2S3, CDS salt, acid dyestuffers. They all are the example of the negative charged salt. We have two types of charge, that is a positive charge salt and the negative charge salt. Okay? Now, the stability of the colloidal solution is due to the presence of equal and similar charges on the colloidal point. These similar charges create a repulsive force due to which aggregation condition does not take place. The positive and the negative charge on the colloidal particle is due to preferential absorption of positive or negative ions present in the dispersal medium. Right. So this is a very simple. So let's see some example. So we know that these are the example of the positive charge salt. So when the Ki solution is added with the AgNO3, always remember when the Ki solution Like we have a Ki solution. When this Ki solution is added with AgNO3, electrolyte we are using this AgNO3. The AgI precipitate will form AgI plus KNO3 will. So AgI precipitate is formed, absorb Ag plus ion from the dispersion medium and form positive charge salts. तो ये कैसा बनाएगा? AgI बन गया. So this AgI will form positive charge. Similarly, when the AgNO3 solution is added with Ki solution to give AgI precipitate, this precipitate absorb iodide ions, I negative. They will form AgI and I negative. So they will form both positive and the negative salt. Clear? Hai? Now, let's see some example and thereafter we're going to solve some numerical related questions, right? So the first thing that is the hemoglobin and gold sol are the example of. So you need to calculate hemoglobin and gold sol are the example of. Jaldi, fatafat. Hemoglobin and gold sol are the example of. Anyone want to say anything related to this question? Hmm? Hemoglobin and gold sol are the example of. I'll give you a 10 second. जल्दी जल्दी reply करो. अभी अभी पढ़ा था ना हेमोग्लोबिन किसका एग्जांपल था? जल्दी बताओ. अभी अभी पढ़ा था हेमोग्लोबिन आर द पॉजिटिव चार्ज सॉल्ट. देखा? while the metallic sulfides हो गया AgS2 एंड गम हो गया स्टार्च हो गया क्ले हो गया चारकल हो गया गोल्ड सॉल हो गया. दे आर द एग्जांपल ऑफ नेगेटिव चार्ज. So क्या एग्जांपल हो जाएगा बेटा? The hemoglobin are the positively and the gold sol are the negatively so. That is option number 2. Right. So option D is absolutely correct for this. Now what is coagulation or precipitation? So just reverse of the peptidation, that is the colloidal particle containing positive or negative charges. Then the repulsive forces between them do not allow them to settle. Right. If somehow the charges is removed, they aggregate or flocculate and settle down under the action of gravity. The flocculation and settling down of the discharge on particle is called coagulation. This is termed as coagulation. So I hope this is clear. What is coagulation? That is when the colloidal particle is converted into precipitate by adding some suitable charges, either positive or negative. So the coagulation of the given colloid can be brought about the following ways: by addition of electrolytes, by electrophoresis, by boiling, by persistent dialysis. So we are in this our syllabus we are going to study only this thing, that is by addition of electrolytes, right? So the most important method among these is precipitated by adding some suitable electrolyte. The coagulating power of iron is described by the Hardy-Squeeze rule. So this rule is very, very, very important. And many times these questions are coming directly from this rule. According to the Hardy and the Squeezes, the precipitating effect of an ion on dispersed phase of opposite charge increase with the valence of the ion. For example, if we have a negative salt, okay, and we have a Na plus, we have a Mg2 plus, we have a Al plus 3 plus, and this we have a negative salt. So for coagulating of negative salt, we need some positive salt. So out of this Na plus, Mg plus 2 and Al plus 3, which one is more effective? So according to the Hardy-Squeeze rule, La plus 3 is more effective, right? So this is all about the Hardy-Squeeze rule. That is the precipitating effect of ion on a dispersed phase of the opposing charge increase with the valence of the ions. So more the valence of the ions, more stronger coagulating power they have. Okay, so this is all about the Hardy-Squeeze rule. For the precipitating of AgSO3, that is the negative salt, the precipitating power of Al plus 3, Ba plus T, Na plus 3 in the order. सबसे ज्यादा कौन हो जाएगा? नेगेटिव है. तो सबसे ज्यादा होगा Al, फिर Ba, and then Na. Similarly, for the precipitating of FeOH3 positive salt, we have a three option: either FeCl3 negative, SO4, and Cl negative. So these having a -2 charge, -1 charge, and they having a -3 charge. So which of the following, that is FeCl6? So FeCl6 -3 is more effective in coagulation. Okay. So the minimum concentration of an electrolyte required in the millimoles per liter, the cause precipitation of the salt is called flocculation value. Smaller the flocculating value, the higher will be the coagulating power of an right? So this is how will you actually calculate. So this is the JEE in 2013 question. Can anyone tell me the answer of this question? This a very simple and weights on the hardest is rule. फटाफट जल्दी से बताओ क्या होना चाहिए. I'll give you 10 seconds for this question. फटाफट बताओ. Till I take some water. जब तक मुझे सबका आंसर आ जाना चाहिए चैट बॉक्स में. फटाफट जल्दी. यस. एक ही रिप्लाई है अभी तक. JNB Gondia, that is B. Okay. Any other? हाँ. JNB चित्रा दुर्गा हेमंत इन्होंने बोला ऑप्शन बी. ओके. Right. So the coagulation power of electrolytes having ions Na plus Al plus to Ba plus for arsenic sulfide. So we know that arsenic sulfide salt. Just wait. Yeah. We know that the arsenic sulfide salt is a negative salt. So for negative salt, we want some positive salt for the coagulation. And out of this, we know that Al plus 3 having the maximum valence charges, right? Al plus 3. So the correct order is Na plus is less, then Ba plus 2, then Al plus 3. Very good. So option B is absolutely correct. So जिससे भी option B बोला, they are absolutely correct. Yeah, Sonali Tikar, इसने भी सही बोला option B. Yeah, very good. Beta. Now move to the some important questions for the surface chemistry. तो फटाफट डिस्कस करना है आप लोगों को सभी इंपॉर्टेंट क्वेश्चंस को. दिस क्वेश्चंस फ्रॉम ऑल सरफेस केमिस्ट्री. ठीक है, पूरे कंबाइन है. So this question come around 2023 JEE main examination, right? So what the question? So given below are the two statement. One is leveled at an assertion A and the other is leveled at reason R. So what is assertion A? So the diameter of the colloidal particle in the solution should not be much smaller than the wavelength of the light show Tyndall effect. So sorry. Though assertion is saying the diameter of the colloidal particle in solution should not be much smaller than the wavelength of the light to show the Tyndall effect. Reason: the light scatters in all directions when the size of the particle is large enough. So out of this, you need to identify which option is correct and which is not correct, right? So let me discuss the first assertion one, right? So assertion is very much correct, beta, because the diameter of the colloidal particle in solution should not be much smaller than the wavelength of the light. If they are smaller than the wavelength of the light, then they do not show the Tyndall effect. So the diameter of the colloidal particle in solution must be uh, bigger than the wavelength of light to show Tyndall effect. So assertion is absolutely correct. What about the reason? So reason is that is the correct explanation of the assertion. That is, the light is scattered in all directions when the size of the particle is large enough. So both assertion and reason are correct, and reason are the correct explanation of assertion. Okay. So this question is from the colloidal optical properties of the colloidal particle. Now, इसका आंसर दो फटाफट. What happens when the lyophilic salt is added to the lyophobic salt? फटाफट जल्दी से आंसर करो. What happened when the lyophilic salt is added to the lyophobic salt? Lyophilic added to lyophobic. क्या होगा? क्या होगा? जल्दी बताओ. What happened when the lyophilic salt is added to lyophobic salt? जल्दी. What happened when the lyophilic salt is added to lyophobic salt? The lyophobic salt is coagulated. Okay, anyone else? देखो, whenever the lyophilic salt is added to the lyophobic salt, they act as a protective layer. Right? How they act as a protective film or layer? Like this is the lyophobic. So this is the lyophobic. So whenever the lyophilic is added, they act as a protective layer. So this is the lyophilic. Lyophilic salt. So lyophilic salt act as a protective layer or protective film for the lyophilic, right? So we can say that the film of lyophilic salt is formed over the lyophilic salt. So option C is correct. So lyophilic act as a protective layer. ये बताओ. This topic we already covered in the first class itself. That is how adsorption is related to the critical temperature. So we have a four gases A, B, C, and D, and they're having a different critical temperature like 5.3, 33.2, 126, 154.3 Kelvin. For their adsorption on the fixed amount of charcoal, what is the correct order? So you need to describe the correct order for this. फटाफट. Critical temperature are given. You just need to identify the order of adsorption. So how will you identify the order of adsorption using the critical temperature? More the critical temperature, more the critical temperature, more will be the adsorption और less will be the adsorption. फटाफट. यही दो ऑप्शन है. अगर क्रिटिकल टेम्परेचर किसी का ज्यादा है तो एडसॉर्प्शन उसका ज्यादा होगा या कम होगा. जस्ट यू नीड टू थिंक अबाउट दिस थिंग ऑन. नो वन. इट्स अ वेरी सिंपल क्वेश्चन बेटा. हमने डिस्कस भी किया था लास्ट. बेटा ऑलवेज रिमेंबर दैट इज adsorption. Let me write. That is adsorption is directly proportional to critical temperature. Those having more critical temperature will be adsorbed more. For example, D having the maximum critical temperature of 154.3 Kelvin. So they are adsorbed easily. So the correct option is D, C, D, and A. D having the maximum critical temperature and A having the minimum critical temperature. So the correct order is. मुझे लगा था कि तुम सब लोग बताओगे करेक्ट आंसर. बहुत सिंपल था क्वेश्चन. चलो नेक्स्ट बताओ. Ferric chloride is applied to stop bleeding. Why? Why we apply ferric chloride? Ferric chloride is applied to stop bleeding. Why? Can specific reason for this? Can anyone tell me? What are the specific reason for this? जल्दी. क्या होगा? Ferric chloride. This is FeCl3. Why this will apply? To stop the blood. This is the blood we have. A. FeCl3 react with the constituents of blood which is a positively charged salt. Okay. First of all, beta, blood is a negatively charged salt. Always remember, blood is a negative salt. तो ब्लड इज अ नेगेटिव चार्ज सॉल्ट. ठीक है, अब बताओ. This is the negative solve. Hmm? This is the negative solve. And FeCl3 is the price. What multiply? That is D. Okay. ये सही बोला है. That is Fe+3 आयन कोगुलेट कर दिया ना भाई. भाई ब्लड को स्टॉप करना है, तो ब्लड को स्टॉप करने का मतलब क्या है कि आप उसको कोगुलेट कर दो, आप उसका प्रेसिपिटेट बना दो. अगर आप उसको प्रेसिपिटेट बना देते हो तो ब्लड का फ्लो रुक जाएगा ना, वहीं पे बंद जाएगा, थम जाएगा. ठीक है. सो व्हाट यू वांट टू मेक द ब्लड precipitated, right? So Fe+3 ion coagulate blood, which is a negatively charged salt. So this is a negatively charged salt blood, and we are adding Fe+3, that is the +3. They are having the +3 charge. So what they did, they coagulate, right? The Fe+3 ion coagulate blood, which is a negatively charged salt. So option D is absolutely correct for this. Okay? Sure. The next question, and this is a very simple question from the physical or the chemical adsorption, right? The enthalpy change for the adsorption process and missile formation respectively are. So सबसे पहले तो अब enthalpy adsorption में बताओ, adsorption में और फिर missiles पे चलते हैं. So we know that adsorption के लिए enthalpy change क्या होगी हमेशा? 0 से ज्यादा होगी? नहीं, हमने पढ़ा था. Both either way I'm talking about the physical adsorption or the chemical adsorption, both are exothermic in nature, right? So for exothermic in nature, their value must be less than 0. Huh? Their value might be less than 0. Okay, their value might be less than 0. So these two options are neglected. इसमें से तो कोई भी सही नहीं है, because in this adsorption is greater than 0. This is not good, right? So for the enthalpy change of adsorption, either option C or D is correct. Now they are same for the adsorption process as well as for the missile formation. So for the missile formation, we know that enthalpy must be greater than 0. This is endothermic reaction, right? So which of the option is correct? That is option number. Okay? Because here the adsorption is negative. We know that for adsorption, the delta change in enthalpy must be negative. And for delta missile formation, it must be greater than. So which of the following represent the Friendlich adsorption isotherm? So you have to identify इसमें से कौन रिप्रेजेंट कर रहा है Friendlich adsorption isotherm को. फटाफट. I'll give you a 15 second for this question. जल्दी से बताओ. Out of this कौन रिप्रेजेंट कर रहा है Friendlich isotherm कर्व को? हमने कल अच्छे से देखा था इसके कर्व को. Which of the following represent the Friendlich isotherm curve? ट्राई करो बेटा, ट्राई फटाफट. ऑल ऑफ यू मस्ट ट्राई. ऑप्शन दिखाऊं? ऑप्शन ऐसा हो सकता है BCD, AB ओनली या ACD ओनली. सो एक से ज्यादा भी हो सकते हैं. ओके, तो आइडेंटिफाई करो. क्या ABCD चारों है? क्या बस AB और D है? क्या बस AB और C है? ऐसे है ऑप्शन. सो यू हैव टू आइडेंटिफाई. इसमें से कौन कौन सा तुम्हें लग रहा है देख के कि दे रिप्रेजेंट द Friendlich adsorption isotherm? फटाफट बताओ, देख के कौन सा लग रहा है तुम लोगों को? यस, आई एम वेटिंग फॉर योर रिप्लाईज. किसी को ध्यान नहीं आ रहा है? नो वन. बेटा, this graph we already plotted yesterday. That is x by m versus p. We'll get this graph like this. Also, in terms of log x by m and log p, we get the graph like this. Here we have a log c as a constant. Okay, or we say intercept. Here also x by m by 1 by p. So we know that x by m is directly proportional to p raised to the power 1 by n. So this graph we already know. That is x by m is directly proportional to p raised to the power 1 by n. So only C is not possible. So out of this, which one is possible, beta? That is A, B, and D. Right. So which option is correct? That is option number C. That is A, B, and D. So A, B, and D. This option is absolutely correct. चलो ये बताओ फटाफट जल्दी से. We have in the figure a straight line is given for the French adoption where y is equal to 3x plus 2.505. The value of 1 by n and log k are respectively. ठीक है? You have to calculate the value of 1 by n and log k. How will you calculate this value? So we know that beta, that is log x by m. Log x by m. This equation will derive multiple times. Log x by m, that is log k plus 1 by n log p. ठीक है? Just compare this equation with this. That is y is equal to 3x and this is 2.505. So 1 by n. So 1 by n, we compare 1 by n is equal to 3. ठीक है? Compare करो. So what is n? n is equal to 1 by 3. ठीक है? So n is equal to 1 by 3. We have. ठीक है? So 1 by n कितना आ गया? 1 by n तो 3 आ रहा है ना? We have to calculate 1 by n only. So they're asking 1 by n. So 1 by n is 3. So two option in which 3 is given. Now calculate log k. So log k is equal to 2.505. So this is a very simple question, beta. Option number 2. Right? So this is one of the simplest question I ever seen on the Fenwick isotherm. Just need to remember the formula. That is log x by m, log k and log p. 1 by n log. So if you remember the formula, you just compare. That is y is equal to log x by m, log k is equal to 2.505, and 1 by n is already given, that is 3. So 1 by n is equal to 3, and n comes or 1 by n is equal to 3, and log k comes out to be 2.505. So I hope this is clear. Sure. The next question is, that is, given below are the two statements, again assertion and reason, right? So assertion, among helium, neon, argon and krypton, 1 gram of activated charcoal absorb more of Kr. तो कह रहा है कि 1 ग्राम ऑफ चारकोल है तो Kr को ज्यादा एब्जॉर्ब करेगी. ठीक है? The reason. The critical volume Vc, that is centimeter cube per mole inverse, and critical pressure Pc is highest for krypton, but the compressibility factor at the critical point Zc is lowest for krypton. So this thing you already study in your chapter 6 of matter in class 11 about the compressibility factor, critical temperature, and all these things. So the question is totally related to this. Let me explain this. Right. So we know that. So what is the molecular order weight? So the molecular weight. So molecular weight का order क्या होगा? Out of helium, neon, argon, krypton. So we know that krypton having the higher molecular mass. Then argon we have. Then neon we have, and then helium. ठीक है? So this is the molecular weight. Molecular weight order. Krypton का सबसे ज्यादा होगा. Now Z at the critical point is equal to 3 by 8. We all know. Z is equal to critical point is 3 by 8. So out of this, A is true. Obviously, A is true because among helium, neon, and krypton, 1 gram of activated charcoal absorb more of K because K having the higher molecular mass. But this is wrong, right? Compressibility factor for the critical point Z is lowest for krypton. So we know that Z is equal to 3 by 8. So this point is absolutely wrong. So assertion A is true, but R is false. So which option is correct? That is option number C. फटाफट इसको मैच करके दिखाओ. बहुत सिंपल है. बहुत बहुत ज्यादा इजी है. फटाफट सॉल्व करो. तुम लोग पहले और सॉल्व करो. आई गिव यू 10 सेकंड फॉर दिस. जल्दी से. लिस्ट 1 को लिस्ट 2 से मैच करना है. देन यू हैव टू आइडेंटिफाई द करेक्ट ऑप्शन. सबके आंसर आने चाहिए चैट बॉक्स में जल्दी से. बहुत इजी क्वेश्चन है. जो भी डिफिकल्ट क्वेश्चन रह रहा है उसको मैं खुद ही एक्सप्लेन कर रहा हूँ. सो प्लीज ट्राई टू सॉल्व दिस सिंपल क्वेश्चन. राइट. फटाफट जल्दी से. Yeah, I got one reply, that is B. और लोग भी रिप्लाई करो. फटाफट रिप्लाई करो जल्दी से. 10 सेकेंड्स खत्म हो गए हैं, फटाफट जल्दी सबकी रिप्लाई आनी चाहिए। नो वन। देखो, बस एक बच्चे ने बोला है, और उस बच्चे ने भी क्या बोला है, ऑप्शन, दैट इज ऑप्शन नंबर बी। ओके, चित्रदुर्गा JNB। ओके, वे चेक करते हैं बी करेक्ट है कि नहीं। सबसे पहले Physios option, Cameos option, analytical approach of the option. So we know that in Physios option, the enthalpy of heat is very, very less. That is 20 to 40 kilojoule per mole. So this is very much correct. That is A having A is equivalent to 2. So A is equivalent to 2. Correct. Now Cameos option. So Cameo suction have a single layer of absorption. This is also correct because in the physio suction, multi-layer is formed due to van der Waals forces. Here chemical forces are involved, so only single layer absorption. So B equivalent to 1. So B is equivalent to 1. So this option B is incorrect, beta. So A is equivalent to B is equivalent to 1. See, देखो, this is an example of heterogeneous catalyst. Why heterogeneous, beta? Because all the reactant and product are in gaseous form, but the catalyst is in a solid form. So these are the example of a heterogeneous catalyst. So C is equivalent to 4. T is equivalent to 4, ठीक है? And D is equal to third, that is analytical application or absorption is chromatograph. So option C is correct, not option B. Got it? Why option C is correct, not B? This question is from the difference between the properties of the Physios option and the Cameos option. So it's a very simple question. ठीक है? Sure. Now, given below are the two statements. One is leveled at assertion, and other is leveled at reason R. So what are the assertion? So in expensive scientific instrument, silica gel is kept in watch glass or in semi-permeable membrane bag. Reason: silica get absorb moisture from air via adsorption, thus protect the instrument from water corrosion, rusting, or prevent malfunction. So in the above light of the two statements, choose the correct option. So you have to identify the correct option for this. करो identify फटाफट correct option. बताओ। ए, JNB गोंडिया ने बोला है ए। That is inexpensive scientific instrument. Silica gel is kept in watch glass or in semi-permeable membrane bag. बिल्कुल सही है. And the reason is that is the silica gel absorb moisture from air via adsorption. बिल्कुल सही बेटा. यानी both A and R are true and R is the correct explanation of the assertion. तो दोनों सही है and they are the correct explanation of each other. Now, the next question is, which one of the following salt solution which coagulate the colloidal solution formed when the FeCl3 is added to NaOH solution at the fastest rate? बोला है as the fastest rate पे कौन करेगा? So बहुत simple question है, again coagulation hard speed rule से है. So which the following है ना? Which one of that coagulate the for this we need whether it is a negative salt or the positive salt, right? So which of the following salt solution would coagulate the colloidal solution formed when FeCl3 is added to NaOH, right? So whenever NaOH and which one is added, that is FeCl3. So NaOH is a negative salt. So if this is a negative salt, अब बताओ फटाफट आंसर कौन सही होगा? This is a negative salt. So which will coagulate first? CaCl2, AlCl2, Na2SO4, Ca3PO4 twice. So if this is the negative salt, then those having the more positive charge. So obviously Al having +3 charge, then Ba having +2 charge, and then sodium plus having +1 charge. So out of these, Al having +3 charge, right? They having the +3 charge. So which will form like AlCl3. That is 10 ml of 0.2 decimeter cube AlCl3. So this will give us the fastest Now, statement 1. For the colloidal particle, the values of colligative properties are of the smaller order as compared to values shown by the true solution at the same concentration. Statement 2 is the colloidal particle, the potential difference between the fixed layer and the diffuse layer of the same charges is called zeta potential. So you have to identify out of these two options which option is correct. Okay? फटाफट. First of all, let me discuss the zeta potential difference, right? So for the colloidal particle, the potential difference between the fixed layer and the diffuse layer, right? Fixed layer and the diffuse layer of the same charges is called the zeta potential, according to the statement 2. This is the false statement. Why? Because the potential difference between the fixed layer and the diffuse layer of the opposing charges, not the same charges. Here the word is mentioned that is the same charges. So this is not the correct one. Right. So for the colloidal particle, the potential difference between the fixed layer and the diffuse layer of the different charges are called the zeta potential. Here same charges are given. That's why they are the incorrect. Now, for the first statement, that is the colloidal particle, the values of the colligative properties are of a small order as compared to the value shown by the two solution. So this one is the statement correct. So which option is correct? The statement 1 is true. Statement 2 is false. So this is the correct explanation. Okay. Now again, this is from the critical temperature. अब तो बता दो फटाफट. This is the same question. Given below are the critical temperature of the some gases, and the gases show least adsorption on the definite amount of charcoal. I'll give you 10 seconds. फटाफट जल्दी से बहुत इजी क्वेश्चन है करो जल्दी फटाफट just observe the table and the values of the critical temperature. No one? It's a very simple question. Guys, फटाफट आंसर्स करो. We have a critical temperature for NH3 405, CO2 304, CH4 190, helium 5.2. The gas is least absorbed. So you have to identify which gas is least absorbed, right? So बताओ जो those having the maximum critical temperature are easily absorbed. So those having the lowest critical temperature having the lowest rate of absorption. Obviously, इसमें ऐसा क्या है? ठीक है? So which option is correct, beta? That is the helium. Because they having the lowest critical temperature. So highest the critical temperature, easy in the adsorption, right? Easily adsorption takes place. So out of these, they are asking the different amount of charcoal, least adsorption. So those having the least amount of least critical temperature. So this is for helium. Now, the next question is given below are the two statements. One is limited assertion and reason again. So assertion is dissolved substance can be removed from the colloidal solution by diffusing through a permanent paper. The reason is particle in the true solution cannot pass through the permanent paper, but the colloidal particle can pass through the permanent paper. So you have to identify out of these two which one is correct and which one is not correct. फटाफट जल्दी से देखो. The first is assertion. So dissolved substance can be removed from the colloidal solution by diffusing through a permanent paper. This is correct. But the particle in the true solution cannot pass through. This statement is not correct, right? Because permanent paper is a semi-permeable membrane which allows the particle of the true solution to pass through as their ties are 2s. Right. So this statement is wrong. That is, a particle in the true solution cannot pass through the permanent paper, but the colloidal can pass. So they do not stop the true solution to pass through them. So this is a wrong thing. So assertion A is correct, but R is incorrect. So this is what we have. Now, Next is for the missile formation, which of the following statements are correct? So you need to answer this. For the missile formation, which of the following statement are need to correct, right? So the missile formation is an endothermic process. अभी देखा था for this delta H is greater than 0. Huh? So missile formation is an endothermic formation. And the next is that is the entropy change is also positive. So which option B? This will not true, this will not true. Option B and C. Yeah. So ऑप्शन सी इज करेक्ट दैट इज दे कंटेनिंग बी एंड सी ओनली ठीक है तो इस तरीके से हम लोगों ने पूरा इसको सॉल्व किया so you also try to solve question related to this chapter surface chemistry in tomorrow class also we are going to solve some numericals related to previous year question and after completing this we are going to do the next topic right so till anyone having any kind of doubt you can ask beta fatafat any doubt till no should we end the meeting ठीक है so this is all इसको एक बार अच्छे से रिवाइज करो एंड देन यू एबल टू सॉल्व क्वेश्चन रिलेटेड टू दिस चैप्टर राइट टिल टेक केयर ऑल कल मिलते हैं एंड वी आर गोइंग टू सॉल्व